and I welcome everyone to the very first episode of our series Node.js Microservices from Zero to Cloud. Viewers, in this series, we are going to build modern, scalable backend systems from scratch. The same kind of architecture used by companies like Netflix, Uber and Amazon. But before we start coding, we need to understand one fundamental thing, and that is what exactly are microservices and why they do matter. So viewers, grab your coffee, open your notes and let's break it down. Let's start with what most of us are familiar with, the monolithic architecture. In monolithic app, your entire project is one big unit. The backend handles authentication, products, payments and orders, all bundled together. There's one shared code base, one shared database and one deployment pipeline. It sounds simple, and really it is like that. It is its biggest advantage. But as your application grows, this simplicity becomes a problem. Let's imagine we are running an online store. You push an update to the order module and suddenly something breaks in the user module. Even worse scenario, every time you want to scale one small part like the product section during a big sale and you ends up with scaling the entire app. That wastes resources and makes deployment risky. Viewers, in short, monolithic architecture come with several challenges. Over here, everything is tightly coupled, meaning even a small change in one part can affect the entire system. And the deployment becomes slow and risky because you have to redeploy the whole system every time. Viewers, a single bug can crash the entire application, bringing everything to halt. And scaling specific features independently is nearly impossible. This is where microservices come in, offering flexibility, fast deployment and independent scalability. Now viewers, just imagine that instead of one massive system, we split our application into small, independent services, each responsible for a single function. For example, a user service handles sign up, login and authentication only. A product service manages catalog data and inventory. An order service takes care of payments and order tracking. Here, each service is like its own mini application. It has its own database, its own logic, and can be deployed independently. These services communicate over lightweight protocols, often HTTP REST APIs or message queues like RabbitMQ or Kafka. The magic of microservices lies in independence. You can build, test, deploy, and scale each part separately. Different teams can work on different services using different technologies. And if one service goes down, the others keep running. It's like turning a big heavy bus into a fleet of small fast cars. Viewers, microservices bring some of the powerful advantages like scalability, flexibility, faster deployment, fault isolation, and easier maintenance. You can scale the parts that need more power at specific time. For example, just boost the product service during Black Friday. Each service can use the best technology for its job. For example, Node.js for user service, Python maybe for machine learning modules, and Go for the payment modules. Similarly, teams can release feature without waiting for the entire system to rebuild. And if the order service fails, the rest of your system still works. Over here, smaller code bases are easier to understand, debug and replace. But viewers, keep in mind that microservices are not free from problems. These have few trade-offs like complexity, communication overhead, data management problems, and DevOps overhead. Managing dozens of small services, databases, and connections is too tough. You will need Docker, gateways, service discovery, and logging tools. Services talk over network, which means latency, retries, and failures can occur. Each service having its own database can lead to data duplication and consistency challenges. More services mean more continuous integration and continuous deployment pipelines and more monitoring over cloud. So remember, microservices solve scaling and modularity problems, but they add operational complexity. You replace one big problem with many small manageable parts. Now viewers, here's a question I get all the time. Should every project use microservices? Absolutely not. If you are building an MVP, demo, or a small startup app, or a proof of concept, start with monolithic. It is faster, cheaper, and simpler. But when your system starts to grow, when you have multiple teams, scaling bottlenecks, or a large user base, that's when breaking it into small microservices. A good rule of thumb may be monolithic are quicker to start but slow to scale, and microservices are slower to start and faster to scale. So don't jump to microservices because it's trendy. Use them only when they are really required. Now viewers, let's look at how real companies use microservices. Netflix was one of the first to popularize them. They moved from single Java application to hundreds of microservices to handle millions of users streaming at once. Uber adopted microservices to separate rides management, driver tracking and payment. Amazon splits its huge monolithic into small services so teams could innovate independently, which became the foundation of AWS itself. These giants did not start with the microservices. They evolved into them as their system grew. That's the same journey we will take in this series. So viewers, to wrap up, monoliths are simple but rigid, and microservices are modular but complex. Choose the right approach for your project size and growth. In the next episode, we'll set up our development environment using Node.js, Express and Docker. And we will start building our very first service. So don't forget to like and subscribe the channel for the next episode. Thank you. Hello viewers, welcome back to the Node.js Microservices from Zero to Cloud series. In the previous episode, we explored the big picture, what microservices are, why they matter, and how they differ from monolithic applications. Today we are getting our hands ready for some real coding. Viewers, before we start building services, we need to set up the perfect environment, clean, consistent and ready to scale. Let's start with the heart of our setup, Node.js. Node.js is the runtime that allows us to run JavaScript outside the browser, making it perfect for building backend services. In first step, visit nodejs.org and download its LTS version for Windows. The LTS or long-term support version is recommended for stability, especially for production-grade microservices. Once downloaded, go ahead and install it using default options. After installation, open terminal or command prompt to run node space -v and npm space -v. Viewers, if you see version numbers for both of them, congratulations. Node and npm are ready. Viewers, no npm comes built in with Node, but many developers prefer using Yarn, a faster and more predictable package manager. To install Yarn globally, simply run the command npm install --global yarn. After the installation, verify it using yarn -v. We will use npm or yarn interchangeably throughout this series. Both work great for managing dependencies in our microservices. When it comes to writing Node.js code, Visual Studio Code is the best editor. It's fast, lightweight, and filled with powerful extensions that make development smoother. Download it from code.visualstudio.com if you haven't already installed it. Once installed, let's grab a few must-have extensions. First of all, ESLint to keep your code clean and consistent. Then Prettier for automatic code formatting. Docker if you will be working with containers. REST client to test APIs directly from Visual Studio Code. These tools help us to maintain clarity and consistency across multiple microservices. Now that we have our environment ready, let's talk about how to organize our code base for multiple services. When working with microservices, it is for sure that your project becomes messy. A clear folder structure helps us to stay organized and scale easily as we add more services. Here's a simple structure we will follow. Each service like users, orders, and products will have its own package.json, routes, and dependencies. The share folder will store code that multiple services might need, like environment variables, error handlers, or database connections. And the docker-compose.yml file will help us to connect everything together later in the series. By keeping each microservice isolated but connected through configuration, we achieve modularity and flexibility. Before we wrap up, let's briefly talk about Docker, an optional but powerful tool for microservices. Docker allows us to containerize each service so it runs consistently across all environments. Your laptop, a test server, or cloud. Download Docker Desktop from docker.com and install it. Once it's running, verify the installation by running docker --version. Later in this series, we will use Docker to spin up multiple containers, one for each service, and connect them via Docker Compose. Even if you are new to Docker, don't worry. We'll go step by step and make sure you understand how everything ties together. And that's our environment all set up. You now have Node.js, npm, yarn, Visual Studio Code, and optionally Docker, ready to build your first real-world microservice. In the next episode, we'll start coding our user service, we'll define our routes, connect to a database, and test it locally. If you haven't already subscribed and hit the bell icon, do it so that you don't miss the next episodes. Hello viewers, welcome back to Node.js Microservices from Zero to Cloud series. In the previous episode, we set up our development environment for our first real-world microservice. And now it is time to develop the microservice. This would be a complete backend tutorial, and we will build a full CRUD microservice using Node.js and Express, starting from the basics and going all the way to a practical file-based database system in coming episodes. We begin by understanding how APIs and microservices work without any data persistence in the first step and using simple in-memory data handling by using get, post, put and delete requests along with services route endpoint. In second part of the video, we will add real JSON data persistence in each endpoint where every user you add, update or delete is saved permanently inside a JSON file just like a lightweight database. Throughout the video, you will learn routing, request handling, dynamic parameters, error checking, file reading and writing, and how to test each endpoint inside Thunder Client and Postman. Viewers, this video will also include a step-by-step walkthrough on how to install and use the Postman for testing of any API or microservices. By the end, you will have a fully functional backend that works both in memory and with real saved data, giving you the complete picture of how modern microservices and APIs manage and store information. So viewers, let's begin by creating a root folder for our first service. Let's begin by laying the foundation for our microservices application. We start by creating a main project folder named Node.js, which will act as the root of our entire system. Inside this folder, we add a new directory called services, where each microservice will live independently. Our first service will be the user service, so we create a dedicated user folder. Inside the user service folder, we will initialize a brand new Node.js project. For that, we simply run the command npm init-y. This instantly creates a package.json file with default settings, allowing our service to manage its own dependencies just like a fully independent microservice. Next, we install the core packages we'll be using throughout this service. We run npm install express no daemon cores. Express will be our main web framework for building APIs. Cores ensures our service can communicate safely with front-end or any other services. And no daemon help us during the development by automatically restarting the server whenever we make changes. Viewers, now we set up a clean and professional structure, a source folder that will help to hold all the core logic. We'll create controllers folder, then data folder for storing JSON or temporary files, but we will keep it inside source folder instead of controller. We also create an app.js file inside the source directory, which will act as entry point for this service. Let's walk through our app.js file. We start by importing Express, the lightweight and powerful Node.js framework that helps us to build APIs quickly. This gives access to all routing and middleware features we will need. Next, we import Cores, a middleware that allows our service to accept requests from other domains or ports, especially useful when our microservices or front-end run separately. Then we initialize our Express application. This app object is the core of our service where we register middleware, route and server configurations. App.use express.json enable JSON body parsing. This means whenever a client sends JSON data, Express will automatically convert it into a JavaScript object we can use inside our route. Now viewers, we will define a simple get endpoint for the root URL. Response.json message sends back a friendly JSON message confirming that our user service is active. It's a quick health check for us or any other service. Now viewers, we choose a port for this microservice. Each microservice in our architecture will run on its own port. App.listen finally starts the server. When it's up, we log a confirmation message to console. If you see this checkmark message in your terminal, you know that the service is alive and ready. Our basic microservice is ready to be deployed on Node.js server on port 4001. We run the server and open the service in web browser with root endpoint / and our microservice is returning user service is running message, which shows that the service is running successfully. After this, we will create user routes file separately and will implement all functional routes inside that file. Now viewers, inside user_route.js file, we will define all RESTful routes for managing users in memory, including creating, reading, updating and deleting user data using endpoints as get, post, put and delete. So first of all, we import the Express library, which is used to create a web server and handle HTTP requests in Node.js. Now a new router instance is created. This allows us to define routes like get, post, put, delete modularly. Now declare an empty array users to store user objects. This array acts as in-memory database for the app. Now define a get route at the root path / of this router. When someone requests this route, it responds with current users array in JSON format. Now we define a post route at the root path / to add new user. Request contains the data sent by client in the request body. Create a new user object. id:\date.now generates a unique ID based on the current timestamp. And request.body spreads all other properties sent by the client into the new user object. Push the newly created user object to the users array. Now respond to the client with HTTP status 201 and return the new user object in JSON format. Now viewers, we define a put route for updating an existing user. \:ID means this route expects a user ID as a URL parameter from client side. Extract the ID from the URL and convert it into an integer. Then update the users array for each user. If the user's ID matches the given ID, it merges the existing user object with the new data from request body received from client side. Otherwise, user object remains unchanged. After that, send a JSON response indicating that the user has been successfully updated. Now define a delete route to remove a user by ID. Similarly, this route also expects a user ID as a URL parameter. Extract and convert this ID from the URL. Filter the users array to remove the user with matching ID. In this way, the user will be deleted. Now send a JSON response indicating that the user has been successfully deleted. And viewers, at the end, export the router so it can be imported and used in other files, typically in Express application. Now viewers, inside the app.js file, we import the user routes module and mount it on \users path. So all requests to the \users are handled by routes defined in the user routes.js file. Now viewers, basics of our microservices are ready to be used, and this is the time to test its endpoints. For this purpose, we'll install and use Postman, a popular tool that simplifies working for testing of microservices and APIs. It provides a graphical interface where you can easily specify a type of request like get, put, post or delete. We'll download its 64-bit installer from its official website. After downloading it, we'll run its setup and join it with your valid email account. In my case, I will connect it with my own Google account. Allow its access from your firewall if it pops up. Describe your role to use Postman and continue with the free plan. Set how would you use Postman, like for testing and automation of APIs. After that, it will show us its testing dashboard. Viewers, first of all, I am testing post endpoint for creation of new user. I am feeding its endpoint URL and setting the body with desired data to save through this post request. On pressing send button, you can see that data has been saved. In next step, I am gonna fetch this saved user through get request and its subsequent endpoint URL. And you can see it has returned user with ID, name and email which we saved in the previous post request. Now viewers, we will use update endpoint with put request and will slightly change the username in the request body. Upon sending put request, it updates the username successfully. Similarly, you can call delete endpoint to delete a user. Now viewers, for testing inside Thunder client, we will open the Thunder client extension and first of all we will copy get endpoint and open Thunder client, initiate new request. We can see that currently there is no user return through get endpoint, as previously saved user through Postman was not saved permanently and on the server restart it vanished. So we will again use add user endpoint here using post command to create new user. For this, just set the endpoint URL and body with the user details to be saved like name, email, ID, and ID would be generated automatically here. Viewers, you can see that the user has been created with the auto generated ID. Now we will update this ID with 1 and slightly change its username through update endpoint using put command. After this, we will verify user details through get command again to fetch the user details. And at the end, we will also use delete user endpoint through delete command to remove any user. In the endpoint URL, we will use user ID which we want to delete and user with that ID would be deleted on posting that request. Now we are checking the availability of that user through ID and also by fetching all users endpoint. Viewers, again if we restart the Node server and start it from the scratch, there is no user available as we didn't persisted any user through Postman or Thunder client. Now we will save the user permanently. So viewers, let's walk through the file handling to store and load our users data from JSON file. This would give microservices simple file-based persistent layer for storing data permanently. We will create a user.json file in the data package. We set some default users data in the JSON format with ID, name and email. For reading and writing data to JSON permanently, we create a file in utils package for the file operations. Here we are creating file.js. Inside the file, we begin with importing Node.js built-in file system module. Next, we import the path module. This would help us to build file paths in a safe and cross-platform way, ensuring our code works on Windows, Mac OS and Linux. Next, we generate a full path to file that will store our users. We navigate into \data and finally point to user.json. This means our service knows exactly where to read and write user data. Next, we define a function whose only job is to read all users from our JSON file. Then we read file synchronously. The second argument UTF-8 ensures the file is returned as reliable text instead of raw bytes. The result is stored in data. Next, we take that plain text and convert it into JavaScript array or object using json.parse. This is function which our routes will use whenever they need the latest user records. Viewers, next we define a function for saving or updating user data back into the file. Next, we convert the user object into JSON text using json.stringify. The null, to part helps to format the JSON with indentation, making it human readable. Then through write file sync function, we write it synchronously to the same user.json file. This ensures our microservice always persists the latest state of data. And finally, we export both functions through module.exports. This would always allow our route and any other module to easily load users and save updates with just one import. And viewers, you see that how our microservices gain simple persistence. No database, yet just clean, reliable file storage that keeps our data safe between server restarts. In later episodes, we'll replace all this with a real database. But for learning microservices, this is perfect starting point. Viewers know that we have set up our basic file persistence layer through file read and write operations. The next step is to adjust our routes so that they may be used this persistence capability to save data permanently. For this purpose, we are creating different root file other than the user routes which was created for routes without persistence previously. We'll name our new file as persistedUserRoutes.js. Here we start by importing Express so we can create route handlers. Next, we create a router instance. These routers act like a mini Express application dedicated only to user routes. Next, we import our helper function. Read users load data from the JSON file. Write users saves updates back data into the storage. This connects our routes to the file-based persistent systems. Next, we define a route that responds to GET request on /users. Every time this endpoint is called, we read the latest version of all users from the JSON file. Finally, we send the entire user list back as JSON response. Now we define our second route to get users with specific ID. Over here, the endpoint handles URL like /user/5, where 5 would be the user ID. We extract the ID parameter from URL and convert it into a number. Then we load all users from the JSON file and put them in the users list. Next, we search for a user whose ID matches the requested one. If no user exists with that ID, we return a 404 error with a friendly message of user not found. And if the user is found, we send their details back to the client as a JSON response. Viewers, next we are defining a route for creation of new user. This route handles new user creation when a post request is sent to /users. We first load all existing users. Then we build a new user object. If users already exist, assign that next ID. If no user exists, start with the ID 1. Spread the request body to include fields like name or email. Then we push the new user into users list. and then we save the updated list back into JSON file using write users function. Next, respond with HTTP status 201 with the message as user added. This is how we can create a new user and save it permanently into JSON file. Viewers, now we will define a persisted route for updation of an existing user with put command. The route with router.put \ID would handle updation of a user by ID. First, load the current list of users, then extract and convert the incoming ID. Then we locate the exact position of the user inside the array. We have missed this line, but we will correct it here. If the user doesn't exist, we return a 404 message. Merge the existing user object with the new values sent in through request from client side. Save the updated list back to the JSON file and then send a success message and updated user as a response to client. Viewers, after that we are defining a route for deletion of user permanently using delete command and persistence mechanism. This route deletes a user based on their ID. We extract the ID from the URL. Then we load all users. If no user has that ID, return an error message with user not found. We give it a status code as 404. Otherwise, we remove the user by filtering out the matching ID. Then we save the users list after removing the desired user into the users.json file permanently. And at the end, we return user deleted response to client side. Similarly, we export this router so it can be attached to our main app.js file under \users. So viewers, up till now we have defined all persisted routes. Now we will test them one by one. We will open Thunder client, and after initializing the new request, we use get command to fetch saved users through endpoint URL. It would load already saved users, and you can see two users loaded from the users.json file. Next, we will update the first user through put command, and in its body we will slightly change the name parameter. And viewers, you can see that there is an error in file.js, line number 14. So we'll open the file, and on line 14 we can see that instead of users, it has been typed use sync external store wrongly. We'll make it correct and will also pass user list as input parameter in the function so that it may handle it. And now upon updating the user, it will update user successfully. Now even after restarting the server, if we again open it in Thunder client and get all users, the updated record of first user is loaded as it have been permanently saved in JSON file. Now viewers, we are creating a new user with ID 3 with name CodingMavrick and email as codingmavrick@example.com. We save it by using post command and create user route endpoint. And now we stop the server and again start it. Upon its start, we again call get all users route, and we can see that the new user with ID 3 is also loaded along with previous users. Viewers, finally we will test the persisted delete user route. For this purpose, we'll use the delete request and its subsequent endpoint URL with ID 3. And when we send this request, the said user is deleted, and if we fetch all users again, it will not load the specified user. We can also confirm it physically from user.json file that whether it has been deleted permanently or not. So viewers, this ends up the today's episode. In today's tutorial, we created complete microservice in Node.js for CRUD operations for user service. We created all necessary packages for a microservice in Node.js. We defined routes in route package for both in-memory data handling and persisted routes for permanent data handling through JSON file. We implemented JSON data read and write operations through read users and write user functions, washed the mechanism to switch between user routes and persisted user routes in app.js file. With this structure in place, our application is ready to grow in modular, scalable way, just like a real production-graded microservice architecture. I hope this video will be helpful for new programmers who are interested in Node.js backend services. Keep watching this series for more exciting stuff and don't forget to subscribe our channel CodingMavrick. Hello viewers, welcome back to Node.js Microservices from Zero to Cloud series. In the previous episode, we developed a complete backend CRUD microservice using Node.js and Express. We used in-memory data handling and persistence through JSON database. And today we are going to take our microservices journey one step further by connecting our Node.js service to a real database, that is MongoDB. Where we will start from absolute zero, so even if MongoDB is completely new to you, you are in the right place. We will perform complete installation of MongoDB on Windows and will learn how to use MongoDB Compass. Then we will connect Node.js microservice to MongoDB. We will create a Mongoose model. We will update our route to use MongoDB and will test our microservice on Thunder client. At the end of this tutorial, you will have a fully functional Node.js microservice connected to MongoDB with a complete database persistence, and you will understand exactly how the entire flow works from installation to API testing. So viewers, let's start the journey. Viewers, we will start with the creation of separate package for this user microservice. I am separating its package with the name users mongo, a bit different from previous package that was users. Now inside the terminal, I will navigate to its folder and will initialize Node project separately for this service through npm init-y command. It will create package file for the project. Now I will install Mongoose, the MongoDB plugin for connectivity of our Node project with MongoDB. Its desired dependencies would be downloaded inside node_module folder. If the project faces express packages not found error, then also copy express packages from previous user service and paste inside users Mongo node module. Now inside user Mongo package, create source folder, and inside source folder create another folder config. This folder will carry dedicated db.js configuration file responsible for connecting our microservice to MongoDB using Mongoose. Viewers, we will start by importing Mongoose, which is the ODM library that helps us to interact with MongoDB using schemas and models. This single library allows us to write structured, predictable database code. Now we create a synchronous function named connectDB. Since database operations are asynchronous, this function allows us to wait until the MongoDB connection is fully established. We wrap the entire connection process inside a try-catch block because connecting to a database can fail for many reasons, and we want to handle those errors gracefully. Next, we use mongoose.connect along with the MongoDB URL. This is the heart of the file. Here, localhost means MongoDB is running on own computer. 27017 is the MongoDB's default port, and user underscore service is the database name Mongoose will automatically create or use. The new parser enabled by setting use new URL parser true fixes bugs, improved parsing of special characters and supported SRV URLs. Next, use unified topology true activate the new MongoDB drivers engine that improves server discovery, monitoring, replica set handling and failover logic. Next, we log the MongoDB connected message. Then we enter the catch block, and here I log an informative error message along with the actual error description. This makes debugging easier by showing the root cause of the failure. Then I would forcibly stop the application using process exit in case of error, because continuing to run the microservice without connected database would cause more errors. This is common pattern in backend apps. Finally, I would export the connectdb function so it can be used in our main app.js file. Now viewers, I will create other necessary packages for our microservice like controllers and routes. Then I will create app.js file inside source folder. App.js file is entry point where our entire microservice is assembled, configured and started. It acts as the main program that Node.js executes to run your service. I will copy the basic code from previous app.js file of our user service and will paste it here. Inside the file, I would shift the user routes object upward in the code for clarity. Moreover, in this file, only two major changes would be made. First, I will import the connectdb, which is database connection function. I will import it from the config/db.js. Next, I will call connectdb function to establish the MongoDB connection. If MongoDB starts successfully, we will see MongoDB connected message, and if it fails, server will exit with an error. And that's it. Rest all things in app.js file are not need to be changed. Now viewers, inside source package, it's time to create model package. Further inside model, create user.js file as a user model. This file defines the structure, rules and behavior of user data inside MongoDB. Moreover, this model acts as a bridge between MongoDB and Node.js application. So viewers, file begins by importing Mongoose, a powerful ODM library. Next, create user schema. A schema is like a blueprint or contract that describes the shape and rules of your data. Here, the user schema defines name as string. Required true means it must exist and we may not skip this field. Similarly, email as string and required true. Now convert the schema into a model called user. A model provides create, find, update and delete user capabilities. It becomes the direct tool used in your routes and controllers to interact with the MongoDB collection. In any Node.js backend, especially in microservices, routes act as the entry point for your service. They define how the outside world communicates with your microservice. Whenever a client wants to get data, send data, update or delete, it always communicates through routes. In our application, previously, the user microservice, all our routes were using file-based JSON storage. But now, since we have integrated MongoDB and Mongoose, we need to transform the routes so that they interact with the real database instead of JSON file. These updated routes will now query MongoDB using Mongoose, return real-time database records, save data persistently, handle async operations, give us real CRUD functionality. This makes our microservice production friendly, scalable, and far more reliable than before. Viewers, first of all, I will copy the existing routes from previous user service. Then we'll create file, user routes, and we'll paste routes here. Then I will change, get, post, put and delete routes as per new requirements. Now viewers, instead of using file-based read-write functions, I will import the Mongoose user model. This model lets us read, save, update and delete user directly into MongoDB. As this model is inside source folder, so I will modify the path starting from source/model/user. Next, our route handler would be of async nature because MongoDB operations return a promise. A promise in JavaScript is an object that represents a value that will be available in future. When we fetch users from database, it doesn't happen instantly. So JavaScript says, by promise, I will give you data later. That later result is a promise. This does not block the program. It returns the promise immediately and results becomes available later. Async and await are modern JavaScript keywords that make working with promises much easier. Viewers, here by writing async before function, we are telling Node.js that this function will perform asynchronous operation that may be accessing a database or reading or writing files or calling external APIs. Next viewers, instead of reading from the JSON file, we will fetch all users from MongoDB using .find method. MongoDB queries with Mongoose and returns promises. So you need await to pause execution until database finishes the query. Without async, you cannot use await. After that, we will send this response to client as a list of users. Viewers, next we will implement the route as getUserById. We will use router.get and /:id along with the use async for database operation. Instead of manually searching in the array, we query MongoDB with user ID. Next, we will return 404 response if user not found from the database. Next, we will return the found user in JSON response. Next, we will start update user route with async db update. We will use findById and update function to update the records in MongoDB. We will update the user based on the ID received from the client side and we will keep new as true because by default MongoDB returns the old document. With new true, it returns the updated document. Next, return 404 status with no user found message in response to client in case no user is found for that ID. Next, return the JSON response with the message user updated and the user object. Viewers, last one is the delete user route